Alright, so we're going to talk a little bit about the periodic table. We're not going to get into it too much. We're going to save that for your chemistry class, but we need to know a few basics about the periodic table. And the first thing we're going to talk about is, you'll notice, all these boxes, all these elements that are kind of lined up here, and we're going to focus on a few of these, especially as we head into organic chemistry and talking about biological molecules, and we're going to focus on carbon. And we're going to get to that in just a minute, carbon being right there. But first we're going to talk about the atomic number, and what does the atomic number of any element tell us. The atomic number actually tells us how many electrons and or protons, because in just this normal state like this, electrons and protons are equal in any element. Now, we're going to not, kind of ignore this whole polarized. I know when we just talked about water, we talked about things being polar and having a slightly positive charge and a negative charge, and that is due to bonding and whatnot. But right now we're just going to focus on what is all contained, because it gives you a whole lot of information, so what is contained in the periodic table. And a lot of what we're going to focus on for our organic chemistry unit are things like hydrogen and carbon and oxygen, some nitrogen right there. Okay, so we're going to focus on these. Often you'll see them written out, like, to remember. Those major ones are HONC, H-O-N-C. Okay, we're going to talk about those. Now, let's go back here and look at what does this actually show us on the periodic table. So the atomic number. So for example, right here, this one, mercury, has an atomic number of 80. That means it has 80 electrons and 80 protons, because we want it to be neutral in this situation, right? It's a neutral element, so it's got 80. There's no polarity, no charge to it like this. So the atomic number tells us how many protons and how many electrons there are. Now, if you were to take that atomic number of 80 and subtract the mass of that element, that would actually give you the number of neutrons. So right around 200 minus 80, you're going to get about 120 neutrons out of that. But we're going to focus on those electrons and those protons. And if you look, carbon, we're going to talk about carbon a little more here in a little bit when we really get into our organic chem. But carbon is somewhat of a special little element, because we deal with what are the available electrons that are available to bond with other elements, and carbon having although it says it has 6 electrons, there actually 4 of those are free, because there are orbitals where these electrons are kind of spinning around the nucleus of the atom of this particular element. And the first orbital you can only have, we're going to say here's our nucleus, and you can only have 2 electrons that are able to float around in here. Alright, and then when we add our second orbital on here like this, so 2 minus 6, because carbon has 6 electrons, 2 minus 6 gives us 4 free electrons in here. Now, this second orbital really can actually hold 8 total electrons. Okay, so the first orbital can hold 2, the second one can hold 8. So let me go and just draw this out a little bit better. Alright, let me clear all this off. Here we go. Alright, so we have, if I can get my computer here to work right. Okay, so we have right here in the center, we have our nucleus. Alright, and that's where our protons, which have a positive charge, and our neutrons, which have no charge. Okay, that's where they hang out. And then around this nucleus of any element, we have the electrons, and they're orbiting around in these little patterns. Okay, And we're going to focus on these first two orbitals. Now, I know you're asking, okay, so how do you get these orbitals? And that is from this little equation, 2n squared, where n equals the orbital number. Okay, so for example, the first orbital here, it's going to be, so let's just do this one. So our first orbital is going to be 2 times 1 squared, which is going to equal 2. Okay? So let's draw our element back on here again really quick. Okay, there's our little nucleus. Here's our first orbital. Here's our second orbital. Alright, so the second orbital then, if we're going with our equation of 2n squared, our second orbital then is going to be 2 times 2, we're talking about our second orbital, this one here, squared. Alright, which 2 times 2 is 4. Alright, we had to square that first and then multiply by 2 and we get 8. So that second orbital can hold 8 electrons. Okay, so let's go back to our carbon molecule that we're talking about here. Our carbon atom, rather. Okay, we're going to be talking about carbon. And it has an atomic number of 8. Alright, so that means in the first orbital, it can hold, it can hold 2, so it's full. It's not going to take on anymore. And the second orbital actually can hold 8, but we only have 4. So this is what makes carbon unique. Okay? Is because now it has 4 empty slots that it wants to fill up with some electrons. So it wants to put some more electrons in here. Alright, and this is what makes it unique, so that it can bond with other carbon atoms, oxygen atoms to make CO2, all these things. So we're going to go back and talk about the periodic table. In the next video, we're going to go back and we're going to talk some more about the periodic table.